Okay, can you all hear me? Nods, thumbs up. Okay, so welcome to this first session in the analytics and storytelling track. This session is about the power of location data and analytics. And I'm Dom Stubbins, I'm Chief Architect here at Esri in the UK. And at Esri, we build the world's leading geographic information system, ArcGIS, which is a set of tools and capabilities and a platform for working with location data used by millions of users around the world, thousands of organizations. And in this session, I'm going to talk to you about the power of location, why location data and analytics is so powerful. And actually, where we are sat right now is a very unique location. If I asked you all to get up now, leave the building, I'm not going to do that because I've let these people in here, but if I did ask you to do that and walk in a different direction for about 15 minutes, and then I drew a map of where you'd all ended up, it would look something like this. Now, those of you who had gone the right way would be enjoying the sun in Holland Park. Some of you would be under the Hammersmith flyover. But where you're standing would mark out an area that's 15 minutes from this location. And if I took that area and then did some analysis, some spatial analysis, compared it with some data that we know about that area, it would be a unique picture of what's in this particular area. And this is some of the statistics. The statistics themselves are not important, but you can see that this area on the left-hand side is very different to the rest of England, which is shown on the right-hand side. Much higher incomes, much smaller households. The way that people spend their money is very different in this area to another area. And if we did that for everywhere in the UK, we would have millions and millions of unique locations, and every one of those locations would be unique and different. And so really, location is an incredibly powerful tool for your business. The power of location is very important if you're looking at how to analyze your customers, looking at your competitors, how do your customers access your business, looking at your supply chain. Many, many different industries and businesses use location data. And so in this session, I'm going to go through what is spatial data and spatial analysis. How can you start to take advantage of that capability by integrating with the way that you store this data inside your businesses? How to work with some of the big data platforms such as Spark, how to work with real-time data, and finally how you can present that analysis and data to the rest of your organization. So let's start with what is spatial data, what is location data? Now, organizations are collecting data in many, many different ways, many different formats, not just things like lists of customers, lists of transactions, that kind of tabular data, but 3D models of their facilities so they can manage facilities, imagery captured from drones for working, looking at your facilities, monitoring construction sites, engineering sites. Many, many different types of data contain location information. And a geospatial platform needs to be able to cope with all of those types of data. And each of those types of data enable you to do different types of analysis and require different sets of tools and capabilities to carry out that analysis. And so what we do at Esri is build those tools to help you as organizations work with all these different types of data. So that's the data, but what's the kind of analysis that you can do with that data? And this slide up here kind of outlines some of the key different ways of working with spatial data. So starting on the left, this is perhaps what we all think about when we think about maps and geospatial data. Where are things? Maps show where things are. And that's the first step in being able to analyze the data within your business, understanding where those things are. Where are they located? How many of them are there? And that leads us in to the second part of analysis, which is about measuring things, not just where things are, but where your customers are. What's the density of your customers? What's the distribution of those customers? Where are they in relation to your stores? How many of them are there? How much money do they have? Being able to kind of drill into the detail of that location. And then we can take that a bit further and think about how different things are related. You know, which customers are near to which stores, which competitors' stores are near to your stores, and what are the relationships between those locations. And then if you want to think about building new locations, how do I find places that are most suited to what I want to deploy? Where are the customers that I'm going after? Where's the best place to put a distribution center to feed all of my stores, for example? And then we can start to look for patterns in the data as well. So looking for, what is it that makes our customers the best customers? What are the what are the soil types that are affecting the way that the pipes that I look after under the ground as a water company are starting to erode? How do I look at those patterns? And why are we doing all of this analysis? We're doing this analysis so that we can make decisions, business decisions. We can make predictions about how things are going to change in the future. And that's kind of the final thing on the slide here, is really about taking those patterns and that analysis and making predictions about where should I be putting up marketing to find my best customers? Where should I be investing in new healthcare facilities to meet underserved areas, for example? So these are all use cases of making predictions, making investments, and using spatial data to do that. And these are just a few examples from some of our customers who are doing this. Being able to deploy new offshore energy, offshore wind turbines. It's a very complicated process. Organizations have to bid for the bits of seabed they want to locate those wind turbines in, and understanding what's there is very important to that process. So in this particular case, they're looking at shipwrecks and debris on the seabed that makes it more expensive to build there. That's an example of finding out where things are and summarizing what's there. Another example is how do I distribute my delivery vehicles to best and most efficiently meet my customers at the lowest cost with the lowest emissions, the lowest fuel consumption. This is an example of how to schedule and distribute vehicles from distribution centers. Another example is looking at accessibility to transport links, building facilities at stations, which customers can access those stations, how do they get there, where do they park, what's the location. It's a supply and demand problem, it's a spatial problem. And then the final example here is looking at health inequalities. Where do we need to invest? In this particular case, it's children being born with a low birth weight. Where do we need to invest interventions, medical interventions, healthcare interventions to help address that healthcare inequality? These are all examples of some of the spatial analysis techniques that I talked about at the start. So, as an organization, how do I get started with understanding what spatial data I have as a business, accessing that spatial data, and using it with some of the tools and capabilities that we build for that? And as an architect, I work with lots of different organizations who are at different stages of their kind of maturity with working with spatial data. And many organizations start out much like the diagram on the left. They have a whole set of business data. Maybe it's addresses, maybe there's some kind of textual location data in there, but it's not been spatially enabled. It's quite hard to do spatial analysis on that data. And to do that, they have to take the data out of those systems, put them into a spatial system and do some separate analysis in that system. And that's fine for one-off use cases, but it's not a scalable approach, it's not a repeatable approach to work with across a business. However, most of the databases that organizations use to manage their kind of operational data, relational databases, for example, actually do support the storage and management of spatial data. So if you're using SQL Server or Oracle, SAP, those systems all actually support spatial data. And really it's a case of enabling that data, turning on that capability, and exposing that data to the analytical tools that you can use. And that allows you to build a much more joined up analytical pipeline for working with spatial data. And increasingly we're seeing organizations take the data out of those kind of transactional systems and deploy them into data warehouse systems. And we've been working with a number of partners over the last few years to make sure that those data warehousing systems that support spatial data can also support the type of analysis and the type of tools that we provide. So we've been working with Amazon to support the spatial data that you can store in Redshift and carry out some of that advanced analysis on that data. Working with Google and the BigQuery database, you can use spatial data stored in that system. And Snowflake as well is another of the big cloud data warehouses that we work with that supports spatial data natively and that you can build on top of with the tools, with ArcGIS and the tools from Esri. So that's the kind of journey that we see organizations go through in bringing that spatial aspect into the rest of their, and joining it up with the rest of their business data. The next section that I want to talk about is big data analytics. Sometimes those data warehouses or those databases are not able to cope with the size, the volume, or the kind of the velocity of the data that you have that has a spatial component. And so we have a component of our platform called GeoAnalytics Engine, which allows you to take all of that spatial analytical capability and deploy it into your existing Spark-based data platforms. So it allows you to deploy that analysis across a large Spark cluster. It allows you to take that analytical capability to the data that you have stored in these giant data warehousing systems and these big data systems. And it lets you work with kind of more unstructured data as well. And the tools that we add to these systems as part of GeoAnalytics allow you to carry out both spatial and time-based analysis of the data. There are lots of capabilities. I think there's about 180 different analytical capabilities that are part of GeoAnalytics now that you can use for working with spatial data, whether that's looking for clusters of data, whether that's looking for at vehicle movements, at mobile phone locations and how those change through the day, calculating statistics about where people are and where they're moving, for example, finding clusters, as well as just kind of common spatial data management tools that you can use within the Spark system. So we support a number of different kind of Spark cloud-based platforms. So on Azure, we support Databricks and Synapse. So if you're using those systems, you can use GeoAnalytics Engine. In Amazon, we also support Databricks and EMR, as well as in the Google Cloud as well. So if you're using any of those big cloud systems, you can use GeoAnalytics. You can also deploy it onto your own systems as well if you're using in-house based Spark systems. So I'm just going to give you a quick demo of how that works and how you would use it to spatial enable a database and carry out some basic spatial analysis on that data. So this is a quick video of the demo. Now, in this example, I'm using Databricks, and I'm using it in the Azure platform. And you can see I'm inside a Databricks notebook, and this is where we'll do most of the analytical work. And then at the end, we'll take some of the data out of this system, and I'll show you some of the visualization. And you can see I'm using a relatively small cluster. And the idea with this demo is I'm going to work with some crime data for the UK. It's quite a big data set. It's not a massive data set, but it's a good example of some of the capabilities that you can do with ArcGIS. Okay, so we're just going to start off by importing the GeoAnalytics library into our cluster. And once we've done that, we can take a look at the new capabilities that have been added into the system. And so you can see there's a list of some of the functions appeared on the screen, and these are some of the spatial functions. I mentioned before, I think there's about 180 different functions, simple things like aggregating data to more complex things like calculating routes, calculating service areas for spatial locations. And once I've brought this capability into the data, into the cluster, I need to load up the data. So I'm going to start by bringing in the crime data. Let's run this. And this data is actually stored in Azure. It's stored as a whole set of relatively unstructured CSV files that get updated every month with new crime data for the whole of the UK. And we can bring that in and start to analyze that data as a whole without having to worry too much about all the different files and how we kind of combine those together. So once I've brought the data in, you can see it's listed the fields of the data, and there's some basic stuff like the type of crime that's there, when it happened, And there is some, you can see there's some spatial information, longitude and latitude, where that crime was when it took place. But at the moment, Spark just thinks that's a string, that's a piece of textual data. It's not geography, it doesn't know anything about where that data is. And we can do some basic kind of non-spatial queries. We can group by crime type to see the counts of the different types of crime in the data set that we have. And you can see, I think there's about 40 million crimes listed in this data set, and we've been able to summarize what those are. But really what we're interested in here is spatially enabling those so that we can look at where those crimes are, not just what they are and how many of them are. And then we can start to look at patterns for those crimes. So the next cell allows us to take those latitude and longitude fields and turn them into some geographic data, a point with a location on the map. And you can see it's produced a new set of data, and down at the bottom we've added a new geometry column that allows us to understand where that data is. And once we've done that, we're able to start doing some spatial analysis. We're able to start aggregating the crimes by area, for example. We've also added a timestamp so that we can look at changes over time with our data sets. Okay, so in the next cell, we're actually going to take all of those 40 million points and divide them up into smaller areas, what we call hex bins. These are, you often see them on maps, little hexagons coloured by the number of crimes in them, so that we can start to see where that data is. So we'll run that analysis. Wait for that to run, and you can see it's given us a result. Now, it hasn't given us a map, it's just given us a list, which probably isn't the most useful way of visualizing the data. It's quite hard to work out what that means. But we also add tools to allow you to visualize the data directly inside of the Spark Notebook environment. So on the final cell here, we'll run this cell, and we're able to take all of those points that have now been assigned a hex bin and visualize that directly inside the notebook. Now, this visualization is relatively simple. It's not an interactive visualization. It just gives you an idea that you can start to look at the data and see how it's distributed. Now, if we wanted to take that further, we can take the data that's represented on the map here and bring it into some more advanced analytical tools that provide an interactive way of working with the data, allow you to query that data, visualize it on more of an interactive map, be able to combine it with different data sets. So this is just an example of a fairly simple analysis that once you've been able to spatially enable the data that sits in your Spark cluster, combine it with the geoanalytical tools and bring it into further tools to enable visualization, whether that's a simple embedded web application, as we see here, or into a more advanced desktop GIS application. This is that same data brought directly into our desktop tool, ArcGIS Pro. So that was an example of taking a large set of data, carrying out some spatial analysis, and then visualizing that in a GIS software, or perhaps you would take that data into Power BI to visualize that, or a custom-based web application. And in fact, talking of that, one thing I did want to bring up is in the next few weeks, we've been partnering with Microsoft to embed that geoanalytics capability directly inside of Microsoft Fabric. This will be going to public preview within the next few weeks, so you'll all get an opportunity, if you're a Fabric user, to be able to start using the tools directly inside of Fabric, and that provides really nice integration with tools like Power BI and the rest of the Microsoft 365 platform. So that's big data. That's about looking at the data that you've got stored and managed within the system, being able to carry out kind of batch analytics, being able to make predictions based on that data. The next thing I wanted to talk about is real-time data. Often the data that you collect as an organization moves very quickly. Maybe you have lots of things that move, vehicles, delivery trucks, containers moving around a port, your supply chain. All of these things move over time. And being able to analyze where those are, where they're moving to in real time is also a very powerful tool. We have a part of our platform, ArcGIS Velocity. This is a cloud-based system that allows you to connect to live data feeds, geo-enable that data, and then carry out real-time analysis against that data and take action on the outputs of that. I'm just going to do a very quick demo of ArcGIS Velocity. This is the dashboard, the kind of user interface, and it's based around the concept of feeds. So these are live data streams coming into the system. Analytics, so this is where you take those data streams, you combine them with other data sets and carry out some type of analytical work on that data before producing an output. And I'm just going to give you a quick example of taking some data from one of our partners, Waze, combining that with some data that we know about vehicles, and displaying that in a dashboard for helping manage a transport system. So there are lots of different types of feed that you can use within ArcGIS Velocity, things like Event Hub, Service Bus, AWS, IoT. You can also connect it to different types of protocol, HTTP, we work with Kafka, WebSockets, lots of different ways of bringing in that live data. And in this example, I'm going to work with the HTTP connector. This will allow me to query an API that's constantly being updated, in this case with traffic information. We partner with Waze, and many of our customers work with Waze to get traffic information, so we can connect to the Waze feed. And the system will automatically poll that data and generate some examples of the messaging that's coming in from that system. It will do this for you automatically. And you can change that and configure it a little bit if it's not quite in the format that you want to display it in your system. So we can make some updates to this. And once we've done that, the system will query the data, bring that JSON down, and try to convert it into a message format. And you can see it's brought in a whole range of data, including information about traffic delays and road closures. And there's also a location X and a location Y. So that's the geographic location. And Velocity will allow us to take that location and start to visualize that data on a map or carry out some analytics and combine it with some other data. So let me just jump ahead a little bit. So this is an example of an analytic. On the left-hand side, we've got our traffic data. We've also got data coming in from the vehicles. So these are sensors on the vehicles, that are buses that are providing the location of those buses. And we have information about bus routes as well. So we can take all of that data coming in on the left-hand side, and we can carry out some analysis. We can look at which buses are near which traffic incidents. So this is an example of a spatial analytic, a spatial join, which buses are near to particular traffic incidents. Do we need to delay the next bus so that they keep the buses are still spread out rather than 3 buses arriving at once, for example? And we can build these analytics in Velocity to carry out that analysis as the data is being updated as we go. And then on top of that, we can build a dashboard to allow a user to manage and work directly with that data. So this is the web-based application that was built on top of that analytic, that big data analytic, and it's for monitoring buses and traffic in New York. The red areas of the road are current traffic incidents that are being reported by Waze. The buses on the pins are where are the current locations of buses in the traffic. And down the bottom you can see we have a dashboard telling us whether how many buses are approaching snarled up traffic areas, how many buses are already tied up in those incidents. And it's a live dashboard that we can interact with and work with to look at that live data as it's being fed through the system. Okay, so that was an example of using ArcGIS Velocity to take live data feeds that are being updated all the time, combining that with other data sources, mapping data that we know about our assets that we're managing, combining those as an analytic, and then visualizing those through a web application. Which kind of brings me on to the final part of the session is, there are lots of tools for carrying out this analytics, and different people will be using different tools to do that. Many of you might be using Jupyter notebooks, and you can do all of that spatial analysis using the notebook environment. You might be using a desktop GIS system such as ArcGIS Pro, or you might be using a more focused web-based analytical system shown on the screen here. But those are tools for analysts to use. They're not necessarily the tools that people in the rest of your organization will use to interact with the results of your analysis or to be able to drill down further into that data. And so direct integration with third-party tools such as Power BI, such as Excel, such as some of the rest of the Microsoft 365 platform are a very powerful way of taking that analytical outputs and sharing them with the rest of your organization. Sometimes you want a simpler way of sharing that data. You just want to present the information. So the application we saw with the buses in New York is a perfect example of building a dashboard that sits on top of the spatial data, combines mapping data and the outputs of your analysis as a simple to use dashboard that presents all of that information to your end users. And then the final and probably the most popular application that we have, the one that's used by most of our users for sharing data and analysis across their organization is what we call story maps. So these are interactive configurable applications that allow you to present not just the spatial data, but also multimedia data, video, images, 3D models, and combine all of those into interactive presentations that you can use to talk your users through the story of your analysis and present the output of your analysis. So that's the end of this session, and I hope you've been able to see something in there that kind of inspires you. Our stand is literally next door to the theatre, just around the corner, so if you have questions for me or my colleagues about any of the things that I've talked about, and I hope the kind of key takeaways from today are spatial analysis is incredibly varied and powerful. There are many types of database and data platform that you can use with spatial data that you can spatially enable. And you can use that data and that analytics across a range of different systems. You can use it with Spark-based big data systems. You can work with real-time data. But it's also incredibly important to think about how you're going to present that data, how you're going to present the results of your analysis across the organization to the stakeholders of your business. So if you want to talk about any of those things, come and find me and a number of my colleagues at the stands next door. Thank you very much.